Hello everyone. Today we want to show you how to model, analyze, and design the combined footing. So for this reason, I have the option for creating the new file. So either from here or from here. So it doesn't matter. So I will start from here. And then after that, I can select the general foundation and then go to open. So select cancel. So as you can see here, we have an empty model. We are going to create our geometry, foundation geometry. For this reason, as previously we mentioned in our previous tutorial, so here we have 4 main steps. So the first one is foundation plan. So it is the, let's say, first step. So the second one is to create the or define the load cases and load combinations. So we will go to see the soil or set the soil parameters. And the last one, we are going to create the job. So in this example, we are going to create the job for combined footing or foundation. So in this case, I will go to foundation plan. So it is nice to mention that once we are defining the, or let's say modeling the foundation from A to Z in a STAAD Foundation Advanced, so then is, normally we can come to column position. So because right now our concentration is on combined footing, that's why, so we don't need to create our grid line. Okay, so it's not necessary. So usually we use grid line for creating the mat foundation geometry. And so after that, we can go to, for example, the different type of grid system that we have, linear or radial grid system. So, but for this combined footing or isolated footing or pile cap footing, so we can simply come to the column position. And from here, the first column position, I can say 0, 0, 0. And in this example, so I want to put another column here. Okay. And from here, I want to have the distance with this column as a 4 meter. So that's why here I will go to this table and look at the units. So it is very important. Always pay attention to the units. Right now, I have the units as meter for defining the length. So that's why here I will go to here and say that in X direction. So as you can see here, I have the Z direction. See here, you have the Z direction. And here I have the Y direction. And in this way, I have the X direction. So then in this example, we are going to position the column in the X direction. So that's why here I put 4 meter. Okay, and then 0, and then 0, 0. Okay, so right now I have this column positioning, and then I can go to make dimension for the columns. So from here, I can say that, the first column, which means this one, has dimension 500 mm by 500 mm, which is 0.5 meter by 0.5 meter. And then the second one, which is this one, I'm going to have the, again, 5 by, let's say, 4. Okay, so I'm going to put this kind of dimensioning for column. So you can put any value as you want. It depends on the project that we are working with. And the next one, I can go to the pedestal. So here, I have the pedestal and anchor bolts. So for example, here I can say yes, yes. Right now, as you can see, I have this pedestal for this column. Again, from here, I want to have the pedestal height. Okay, so from here, I want to have the pedestal height as, let's say, 300 mm. And then here, I have the pedestal. Maybe I can go for 400 by 400. Okay, so I want to apply this dimensioning to both pedestal. So for this reason here, the height, so I will put as 0.3 for both, 0.3. And then here for pedestal length, for the first column, which means this one, I want to go for by 0.4 by 0.4. And for the second one, I want to put 0.4 again by 0.4. Okay, so it is for definition of pedestal. So here I have this. And then the next step, I can go to the load and factors. So under load and factors, first of all, so I need to create new load case. So from here again, if I want to show you, so we are working with this option. And also here, I'm going to use the load combination. So the first one is the manual way, and the second one is the automated load combination generation. Okay, for the first one, I will select and create new load case. And from here, so I have the parameters. For the load title, I will put dead load. And then the type of the load. So here I have the primary, service, and ultimate. So I'm not going to assign the dead load as service or ultimate. So later on, I will go to the load combination and I will have them as load combination. But for now, just I will select the primary load type. And the loading type also I will select as dead load, because here I'm just selecting dead load and then click add. So right now I have dead load here. Okay. And also I'm going, to maybe create another dead load. For example, one dead load with different, value for this foundation, for foundation number 1, and another dead load with different value for foundation number 2. So that's why here maybe I can say dead load 1, or let's say here dead load 2 to represent as for the second footing. But for the previous one, here just I put dead load, but here I can edit it. So I can put 1. Okay, so I can put 1 for this one. As you can see, simply you can edit it. And then for the second one, so again, I will select this load, or I can go to the create load cases. And from here, I have the load case number 2. And here I can say LL or live load. And then from here, I will change the loading type to live load. And then again, but before that, so here I have the dead load 1 for footing number 1. And here also I will put live load 1 for footing number 1. Okay, so from here I can add this. So same procedure, I want to have the, specific dead load and live load for footing number 2. And that's why here I have the load case number 3. So from here I can say dead load 2. And again, here I have the dead load as a loading type, and then add. So here I have this. And then from here also I can go to the another one, which means here I have the live load for footing number 2. And from here I can say live load, and then I can add. So as you can see here, I just created 2 types of dead load and 2 types of live load to be assigned for footing number 1 and footing number 2. So let's go to assign the loading for dead load number 1 and assign to footing number 1. So for this reason, I can just right click, and then here I have 2 options. I have add column reaction load, and also I have the add point load. So what is the difference between these 2 options? So once I'm clicking add column reaction load, so means that so I'm directly at the load at the center of the pedestal or column. Okay, so I'm applying the load here. But once I'm again right click, I'm using add point load, so which means I can put the load so anywhere that I want. Maybe I want to put the load here, or maybe here, or maybe even at the at the corner point here. So I can do that. That's why the difference between the add column reaction load and add point load, which I can show you right now. If I click add column reaction load, see here what happened here. So I have the forces and moments. So that's why here, as we said, so it will be directly assigned to the center of the pedestal or column. But once I change this one to add point load, here I have extra option. So here it is the position. So here I have the position, and then here I have the position in X, Y, and Z. So that's why here simply I can put the load whatever I want to be. Okay, but for this example, I'm not going to use the add point load. So just simply I want to add the column reaction load. So for this reason, I will select this. And here I'm going to apply the Fy, because here, again, as you can see, so here I have the Y direction. So in most of the cases, we have the, gravity load at least. Okay, and then here the direction should be negative. Okay, and always actually, this gravity load exists. That's why, so always we need to have this Fy load. So for this reason again, so I will come here and say that minus, I don't know, maybe 40. And then from here, maybe I can add also one, torsion load, which is just around the Y local axis. So with the magnitude of, let's say, -5, for example. Okay, right now I created this, and then it is under load case 1. So then I can add. Okay, so right now I have this loading here. So the second load for, let's say, first footing that I want to apply is live load. And from here, again, I can right click, add column load. Here I can say, for example, -50. And again, here also I want to have the one torsional load, which is a moment around the Z, around the Y local axis. So here I can say that minus, for example, 8. And then again from here, I can press on add. Okay, so right now I have these 2 loads, dead load 1 and live load 1, to be assigned to this footing. And then here I will go to the second footing, right click, add column reaction. So again from here, maybe I can assign minus 25 kilonewton. And this time I want to assign, again, maybe here I can go to assign the, let's say, moment about the x-axis. So here I can say 3, for example. Okay, and then add. So here I have the dead load for footing number 2, and also I'm going to assign or define the another live load for footing number 2. So for this reason, again, I will put minus 35, and then mx I can add as 6. Okay, and then add. So right now I have all these load cases. Okay, and from here I will assign this load cases to each footing. For example, under dead load 1, we know that we need to assign to this footing, footing number 1. That's why from here I will change the assign to view to assign to selection. And then I need to select footing number 1 and then assign load. See here, already assigned. So I can go to the live load, and from here again I will select this load, live load, assign to selected to selection. So already this footing is selected, and then assign load. So right now also I have this one. So I can go to the second footing and second load cases, which means the first dead load for footing number 2. Okay, and from here I can select this footing, because here I can simply assign to selection. Okay, and then assign load. So right now I have this one, and as you can see here, you have the moment about the z-axis, x-axis. And the last one here, I will go select this, and again this footing is selected. So here assign to selection, and then assign load. So here I have this loading. Okay, so far is nice. So I can, even if I want to scale up or scale down the loading, so I can go to Home tab here, and then here you have the scale setup. So if I click on this, here I have the point load. So from here, if I reduce the scale, see here, you can see the point load and moment as well. So here I have the point moment. So here you can see. So from here, you can change the scales of the loads. Okay, so now I can go to load generation. So here we said that we need to use this load combination. The first one is the manual one, as we said, and then the second one is the automated one. This one is automated one, and that's why here, after clicking on this generated load combination, so you will have this type of loading. And from here, maybe I can change the, the loads. If you want to assign your own load combination, so you can use the user define. And from here, you can change this load types. For example, here I have the dead load and live load. For service load, I can say 1. As you can see here, so this after changing 0 to 1, so it will be highlighted with the blue color, so which means it's selected. And then you can generate load combination. But for now, so I'm not going to use this way. So let me go to first to show you how we can create the load combination manually. So from here, I will select the create load combination. As you can see here, I have the load combination. So from here, if I want to include the load combinations, so from here, I can select all or include all load combination. So right now I have it here. And if I want to select them or define them as a service, so here I have the two options, service and ultimate. Okay, so if you are going to put the service load, so from here, you can put all values as 1. If you are going to assign as ultimate, so here you can change the factors for different loading type, which means dead load and live load. Okay, in this way, let me just show you for service load. So I can say service load, and here also I can name it as SLS, okay, service limit state. And then I can add load combination. See here, I have the load combination, and here I have it. Okay, but right now, it is the manual one, but I want to remove it. As you can see here, if you want to remove any load cases or combination, so if you right click, you don't have any option for removing or deleting the file, the load. So what we can do, so you can go to here, this option. You have the remove load cases. Okay, so you can select this SLS or service load and then click on here, remove load case. Yes, yes. Okay, so I just remove it. So now you know how to generate the load combination manually, but right now also let me to show you how we can generate the load combination automatically. So here I can go to generate load combination. In this example, I'm going to use the British code, and from here I have the service load combination. I have the service load combination as well as ultimate load combination. Okay, so what can I do? I can simply, after selecting the British code, so from here also, if you want to change the load combination number, so you can change it. For example, here I have 1, 2, 3, 4. So from here, you can change it to, for example, 5. And then generate load combination. Okay, so here, load combination generated completed. So here you have this load combination, which means or it is SLS or service limited state. And also here, so right now I have load combo up to 36. So here we have the 36. So from here I can say 37 to have a nice load order for numbering. Okay, and from here I'm going to define ultimate load combination. See here, maybe in this service load, so I have many service load. However, here I have only dead load and live load, and maybe I need just, to create one service load, which is, with the factor under dead load with 1 and live load with the factor 1. But here, as you could see, so the software automatically generated so many loads for me. So because here I have the fluid load. Okay, so if I come to this view, okay, so I have active air pressure load. So here with the factor 1. So all this, let's say, load combination already have been included in my service load, which actually I don't need it. Okay, so for this reason, I'm going to show you here under ultimate load combination to how to avoid this, avoid this plenty of load combination. So simply you can come here and then uncheck. So the second one is the factor 1 and 1.6. So I don't want, maybe I need this. So the third one is this 1.4. The fourth one, I don't need it. Okay, so here I don't need it, I don't need it, I don't need it. And from this way, just I can uncheck these options. Okay, so I don't need them. Okay, and I know also under, let's say, British code. So here I need number 4 as well, because here I have the factor 1.4 for dead load and also 1.6 for live load. So here I can check this option. And then also I want to remain number 2, number 3 as well, because here I have 1 with 1.6 and here I have 1.4. That's it for dead load. So then I can generate load combination for ultimate. Okay, see here, I have the 3 ultimate, 1, 2, 3. So if I close this, here you can see you have the ultimate number 1, number 2, and number 3. So in this way, you can avoid many load generation because we don't need it normally. Okay, so let me go back to the next step. I can go to soil properties. So from here, if I click on this, so here you have all these factors. Okay, so which means you have the soil bearing capacity factor under different load cases, which means dead load and live load and different load combination. So here we have a plenty of service load that we said we don't need them. If you want to remove them, so you can go back to load and factors. And from here, so maybe only we need actually, this one, it is dead load and live load. Okay, so it is dead load and live load. But here it is dead load 1 and dead load 2. Okay, so maybe I can just remain this loads, service loads. The rest I want to remove. So for doing this, again, I can come to here, okay, and then I can remove it from here. Or simply I can just come here and then so I can select the load, and on my keyboard I can just press delete and enter, because here by default yes is selected. Okay, so I can press yes. So in this way I can put again just delete and enter. Okay, delete, enter, delete, enter. Okay, delete, enter, delete, enter. And I will go to continue to remove my redundant service load. Okay, so right now I have this, and then I can accept it. Make sure you save your model. So after that, I can go to the job setup, which is the main steps, but number 4. Okay, so I can just okay, open. Okay, so from here I can say that combined foundation. Okay, save. And then from here I can just open job setup. So from here I can go to create a new job. From here I can say that combined foundation, and the type also is combined, as you can see here, and the design code is British code. The unit system is SI, and support assignment, so I'm going to assign to all support, which means this to support. And from here, so I'm going to select all these load cases and combinations, and then from here I can create the job. So job combined foundation has been successfully created. Okay. And now from here, I need also to create the strip footing. So for doing this, I can select it. As you can see here, I can select this to footing. And here I have the create from selected nodes. Okay, created. So right now I have the foundation, combined footing. So after doing this, so here a new file or a new job under name of combined footing will be created. And from here, I can just again expand this option. So here I have the some setting. So the first one is concrete and reinforcement. So from here, I have some default values from my previous project, but you can set the values as you want. For example, here I have the unit weight of the concrete, so it is 25. Minimum bar spacing is 100. Maximum bar spacing is 300. And strength of the concrete, I just put at 30. Yield strength of the steel, I just put as 415 megapascal. Minimum bar size for footing at the bottom side. So I just selected to be 10 and number 20. And for top reinforcement, the minimum I selected to be as 10 and maximum I just selected to be as 20. And here I have the minimum pedestal bar size. So again, from here, I just selected to be as 8. And for maximum pedestal bar size, I just selected to be as 20. And from here, you can just save it as default by changing no to yes. And the next one, I can go to the cover. Again, I have all the, let's say, default value from my previous project that I did it for myself. So the most important thing is here, fixed top. So if you look at, our previous tutorials regarding, this parameters, so you will find out, a detailed explanation about, all these parameters. So you can find, our previous tutorial in the description of this video. Okay, so I can accept this, and then I can go to the footing geometry. So again, so I have all this, values, again set from my previous parameter setting. Okay, and here I need to explain something for you. Here I have the design type. So here I have the calculate dimension, and also here I have the set dimension. If I change the set dimension here, as you could see, all this maximum length, maximum width, maximum thickness, and also length increment and thickness increment will be uneditable. So why? Because I'm forcing the software to design the foundation according to the footing geometry that already I defined. For example, here I said that the minimum left cover overhang length is 1 meter, which means if I go to the top view from here, so here I have the overhang. Yeah, so here, let's say here it is my footing, and if I want to have the overhang, so which means here it can be overhang. Okay, so here I'm saying that minimum left overhang length, which means in this direction, and also here I have the minimum right overhang length, so which means here. Okay, and also I have the minimum width for this overhang. For this footing, so which means here 1.5. Okay, and minimum thickness, so it is for foundation depth, which means here. Okay, so I'm just forcing the software to use, or just to go for 500 mm. If I select the set dimension, but if I change this set dimension to calculate, so right now you can see all of this parameter will be activated, because I can tell the software to design the footing in a specific range. So for example here, so if the minimum thickness of the footing, if I defined as 500 mm, which means here, okay, so if after the first iteration, if the software couldn't come up with a proper solution, so here I have the increment or thickness increment as 50 mm for the next iteration. So which means if this depth wasn't enough to carry out the load, so here the software automatically add another 50 mm to have the, another thickness. Okay, so in this way, so you have the, let's say, thicker foundation. If again is not satisfy the result, so again the software add another 50 and so on, so forth. So again from here you will have another, or let's say, thicker foundation, just like this. Okay, so here it is the procedure. Once we are selecting the calculate dimension, so and the range, so also we can specify it, because here, so here we have the minimum thickness 500 and maximum thickness here I have 1000 millimeter, which means 1 meter. So if it reached to 1 meter and still it couldn't, pass the design, so then the report will be come up with the failure. So that's why from here, so for the first try, so you can add, so here I can say that go to, let's say, 2000 millimeter. And from here, maximum width, so I can say go to 4 meter, and also maximum length, go to 4 meters. Okay, so in this way, and minimum width here is 1.5 meter. So pay attention to the units. And here I have the minimum right overhang length. So here I have 1, and then here also I have overhang length in the for the left side or another side. So here. Okay, so now I can accept this values and then click yes. So here I'm also saying that, fix left overhang. So if I press yes, so which means, so the software only can go up to, 1. Let's try this. So we can say just we want to force the software, to fix the width, fix the right overhang, and also fix the left overhang by 1 meter and 1 meter. Okay, so we can accept this. And now I can go to the next step. So right now I'm in the footing geometry. So here I can come under column eccentricity. So here, if I want to have, any eccentricity for the footing, so I can put it here. So for the eccentricity, as you can see here in this view, so if I put something here, so it is for in the X direction and it is for Z direction. If I put, for example, here, I don't know, 0.5, so which means I'm shifting the column by 0.5 along the X axis. Okay, and then I have some eccentricity. If I put, let's say, 0.3 in the Z axis, so which means I'm shifting the column, so from the center, to somewhere here by 0.3 meter. Okay, sorry, here the unit is centimeter, so then you need to come up with a good, or let's say appropriate number. Okay, but the concept is like that. So if you are putting something, so which means you are, shifting the column from the center of the geometry, and then definitely you will have some eccentricity. Okay. Then I can go to the sliding, but for here, I'm not going to, put any eccentricity, so just 0 and 0. And then here, I have the sliding and over turning moment factor. So here I can say that, coefficient of friction, let's say here I can put 0.5. And then here, factor of safety against sliding, I can say 1.5, and also factor of safety against overturning, I can accept it as 1.5, and then I can save it as default. So if in new file, if I open this, so I have all these options, and I don't need to waste my time once again. So that's why, so I can save it as default. And the last one, so here I have the design option, or also here I have the design or analysis tab. Okay, so either I can select on this or select on this. No different. Okay, so I can remove them, and then, so I want to run the design, save. Okay, so hopefully we don't have any error. If we got any error, so we need to solve it. Let's see what happened. And after come up with the design, so we can see the detail and schedule drawing. So we can go to the calculation sheet. We can go to the GA drawing to see the the general arrangement of the foundation. And let's see first. Okay, so we have no error, no warning, and then that's it. So here we have our design. Okay, so I can select here. I can just open this, and from here, just by pressing Control and playing with the mouse scroll, so you can maximize or minimize this page. So here we have the pedestal. So if you remember, we just put 300 mm. That's why here we have the 30 centimeters, and then so we said that the minimum depth of the combined footing. So we said that 500 mm. So that's why here I can see 500 mm. And then overhang, if you remember, we force the software to design the overhang by 1000 mm. That's why here we have this. And from here, maybe I can explain better. So here it is the overhang. So at the center of the column up to edge of this footing. So it is overhang, or let's say right overhang. And here, again, from the center of the column to here, we have the left overhang. And again, from here, we have the 1 meter as we force the software to design in such a way. And also here, just I'm reviewing actually, what design parameters we defined for our, foundation and column and pedestal. So for the pedestal, so I just, if you remember, assign the 40 by 40. That's why here I have the 40 by 40. And if I come down, so here I have the 1.5, because again, if you go back and check the design parameters, or let's say footing geometry, so here you will find out, or let me show you. Here. If I go back to just remember this, it is 1.5 meter. Yeah. If I go back to footing and geometry, so here maximum width is 1.5. That's why here I have 1.5 meter. Okay, and then the rest is a very, very detailed calculation. At the same time, is very summarized. So which means this report actually directly takes you to the main point, main calculation, report. Unlike other, software, because in many software we know that after generating the report, you may have 100 pages, but right now in this STAAD Foundation Advanced. So if I just want to see how many pages I have, so simply I can come to the here. So either at the top, print calculation sheet. Okay, so I can just press on this print button, and then from here I can say that I want to save it as PDF. Okay, so I can accept it, and then here I can say print. Okay, it's trying to print it out, and right now here I have the PDF file, and the page number is only 11 pages. It's very summarized, and as we mentioned, at the same time is very detailed. So for now, I can just export job from here. So it depends on which kind of let's say PDF PDF reader application you are using. So you can just save your file. So from here I can I can save the job. Okay, so excuse me. So here, so from here I can save the job as PDF. So here I have the PDF, and then here I can say that again, combined foundation report. Okay, so I want to put it in the desktop. Okay, and then save. Okay, that's it. And then so you can just review the calculation. For example, here you can go to the stability check. So here you can see the stability check. And then here you have the check for stability against the sliding. You can see the check stability against the overturning. And then here you have all this information. Okay, so you have the moment diagram. And then you can go to check the punching shear. For example, here you have the very detailed calculation, step-by-step calculation report, and then design of the, let's say, reinforcement, and also pedestal design. So here you have the pedestal design. If you go to the detail and schedule drawing, so here you have this drawing. Okay, and so here you will get all the information that you need. So here you have the link for the pedestal. Okay, you have the reinforcement. So here at the top, for example, you need to provide 13 number of reinforcement with the 10 mm dia, and at the bottom, you also same. But in this direction, you want to provide the 15 number of bars with the 10 mm dia for the top portion of the foundation, and 49 number of bars with the 10 mm dia for bottom side of the foundation. Okay, so from here, you can see the other views and information that you may need. Okay, so I can go to GA drawing. So here it is the GA drawing, or general arrangement drawing. So here I have putting number one, the pedestal or column position number one and number two. And here I have the combined footing. So here also I have the dimensioning of the footing. So the footing actually is just 600 by 150, and then the depth is 50 centimeter. Okay, and then so already we talked about the calculation sheet, and that's it, guys. So we already did it, and hopefully you enjoyed the video. If you have any comment, any suggestion, so you can put it at the comment. Thank you for your attention, and please subscribe to our YouTube channel for getting the most updates, tutorials, and videos. Thank you so much.